Hello guys, in this section we are going to be building our own very first graph and we are going to be building the reflection agent using some of the chains that we built in the previous section. So you can see that I've already gone ahead and created a simple file called basic.py alongside with the chains.py that we created in the last section. And also you can see that I've imported a few things. Before you start importing it in your own code, just go ahead and make sure that you've installed this particular package, LangGraph. Okay, so this is going to be the command, very simple. Just do that and you should be able to import some of these things. All right. So let me walk you through what are the things that I've imported. So we have the from typing import list sequence. This you can think of it like a very simple type checking class, like very similar to TypeScript. Not really important for the actual execution of the graph, but it helps us make sure that there aren't any errors. And then secondly, we have the .env, which we know, it basically just like loads up all the environment variables. And then we have the messages classes, the base message and the human message. I think if you've worked with LangChain, you should be pretty comfortable with it already. And then this is what we are going to be doing a little bit new. So we are importing from langgraph.graph. We are importing the end class and the message graph class. Okay, so this is pretty important. We will come to this in a minute. And then finally we have from chains and we're importing these two chains that we have written in this particular file right here. Okay, very, very simple. So let us quickly take a detour and really understand what this message graph is all about so that we can confidently proceed forward with the rest of the code. So let us see what is a message graph. So it is a class that LangGraph provides that we can use to orchestrate the flow of messages between different nodes. So this graph that you see right here, this is going to be a message graph that we are going to be using. So the example use cases are simple routing decisions, simple chatbot conversation flow. And what we are doing is something that is very basic. So we are going to be going with the message graph. So if you just want to pass messages along between nodes, then go for message graph. Okay, so we will look at what this means in a few minutes. And there is another type of graph, which is a state graph. And if your app requires complex state management, then we can go for state graph. We'll look at more of this in the future. But for now, for this particular use case, we can actually use the message graph. Okay, so let's actually dive deeper into it. So to put it simply, message graph maintains a list of messages and decides the flow of those messages between nodes. So every node in message graph receives the full list of previous messages as input. Each node can append new messages to the list and return it. The updated message list is then passed to the next node. So basically each of these nodes receive as the input all the previous exchanges that happened, and then each of these nodes can actually receive the entire list and then append another output, a response, and then send it to the next node. And then the next node can do the same thing. It receives the entire input and then it can use that and generate a new response and then append it to the list and then pass it back to generate and then reflect and then generate. So that is a very simple workflow, and that is exactly why we are going for message graph. So let us actually now go ahead and start building our own graph. So to do that, I'm just going to come down here and then I'm going to invoke the message graph class. So I'm going to call it graph, message graph, and then I'm going to invoke it. Perfect. So we have the graph ready. Now there's a couple of things that we have to do. So the graph is currently empty, right? So I'm just going to first go ahead and create the generate node. And then I'm going to go ahead and create the reflect node. So once I have all the nodes ready, I'm going to add it to the graph and then I'm going to connect those nodes together. Okay. So it's very much like, drawing a diagram and then controlling the flow of, the control flow between nodes. So first off, I'm just going to, name the nodes properly. So we have the generate node and the reflect node. So to make it easy, make our lives easier, I like to usually go ahead and create a constant like this. So reflect and then generate, right? Generate. All right, perfect. So now let's go ahead and create the generate node, and that is nothing but a simple function. All right. So I'm just going to say generate node. And if you remember from the previous slides, we know that every node receives the entire state. right? And then we are invoking on that state using the chain that we've created in the previous section, and then we are appending that response to the history. Okay, so that is what we are going to be doing. So this is going to be the state. You can basically think of it as a list of messages that happened in the past. Okay, so this is going to be the list of messages, and then this we can actually make use of the generation chain, and then we can invoke on it. So basically whatever state has been generated or accrued, all of that we need it to sit right here. Okay, so we have the messages placeholder. So let's actually go ahead and say messages, and then we pass in the list of messages, and that is it. So what this is going to do is it is going to generate the tweet based on whatever is existing in the past. So later on, when we actually invoke this graph, we will provide the prompt, the main user prompt, and that is going to be what is appended, and it's going to be provided right here. Oh, and also don't forget to return this particular thing. So whatever is going to be the returned object of the LLM, it is just going to extract the content property alone, and then it is going to append that message to the existing state right here. Okay, I hope that makes sense. Let's now go ahead and create our next node in our system, which is going to be the reflect node. So I'm going to say reflect node state. So here we are going to be doing something very similar. So here we are going to be using the reflection chain, and then we are going to invoke the messages, and then finally the same state. Okay, perfect. So I hope that makes sense. There is also one more thing that I want to do. So we have the generate node. Obviously, the generation is being taken care of by the AI, and whatever is returned is considered to be the AI message. But usually in real life, the reflection is being done by a human, right? So we can actually trick the system into thinking that the message that is being returned is by a human, right? So we can also do that. So I'll tell you how. So we can actually call this to be the response, and let me just paste something here, return response. Okay, so we can also do something like this. So the previous version, that is perfectly fine as well. First AI is generating, the second AI is critiquing. The first AI is generating, the second AI is critiquing. That works perfectly fine. But for readability, for tracing using LangSmith, etc., sometimes it might make sense if the reflection is actually if we are tricking the system into thinking that the reflection is being done by a human. So in that case, we can actually return a list, and we can just pass in the content right here, and this content is going to be appended to the existing list of messages. Okay, so this is also a possibility. I'm just giving it to you. But if you don't want to complicate your system too much, we can just leave it as it is as well. Okay, all right. So we've already gone ahead and created both these nodes. Let's now go ahead and add these nodes to the graph. So to do that, it's very simple. I can just say graph, add node. And in this node, the first one is going to be the name of the node, and then the actual function, the generate node. And then secondly, we also have, let's also add the next node. So we can just say reflect, and then reflect node. All right, perfect. And also we can, specify the entry point. Okay, so there is always going to be an entry point. So in this graph, if you look at the entry point, it is going to be this generate. You might ask, okay, why is it not start, right? So the answer to that is start is something that is like, inherently sort of assumed to be the entry point. So it's not really considered, explicitly considered, it's more like implicitly considered. So let's actually use the generate node, which is going to be the first node where the entry is going to happen. So I'm going to say the entry point is going to be this particular generate. Okay, so let's come back to the diagram. Let's see what else is there. So we now need to create this particular should continue function. Okay, so the should continue function is basically keeping track of how many iterations have happened. And if, we can actually set, okay, after 4 iterations, you stop the cycle, go to the end, give the user the end output, which is the more refined tweet. So until then, just like, after the generate, come here, go send it to the reflect instead of the end. So it just does this 4 times, and then it is going to go to the end, right? So let's actually go ahead and write this should continue function. So to do that, I can just say should continue, and this again is going to get the list of messages. And here I can say if the length of the state, if that were to exceed 4, Okay, in that case, I want the graph to end, right? So I can just say end right here, and you can see that I've already imported this thing from the graph, right? It is a pre-built constant, and then if that is not the case, I can just return the reflect. Okay, I can say go to reflect. Okay, so far we've created the generate node, the reflect node, the should continue node, right? We've also specified that this generate node is going to be the entry point as well, but we haven't really done any sort of connecting yet. So the first connection that this is going to be the connection, right? So these edges are going to be the connection. So the first thing that I'm going to do is I'm going to say add conditional edge. Okay, so the conditional edge is going to be this thing right here. Okay, so right after this should continue, it can either go to the reflect or it can either go to the end, right? So this is going to be a conditional edge. This is not going to be a normal edge. So what you see right here is a normal edge. What you see right here is a normal edge, but this is going to be a conditional edge. So what I'm going to do is I'm going to say right after the generation is done, right after the generation is done, this should continue node is going to actually, branch off to two different things. Okay, so that is why we are putting this add conditional edge right here. Okay, I hope that makes sense. So far we've done this particular connection. The should continue should go to reflect or should continue to go to end. But if it were to go to reflect, then there is only one option, which is to go back to the generate, right? So let's actually connect an edge between the reflect and the generate. So to do that, I'm just going to add a very simple edge. So this is called add edge. Okay, this is not going to be the add conditional edge. So the first one is going to be reflect. So this is going to be the from node, and then we are going to have the to node. So you can imagine that this is very much like just drawing a diagram, right? So we've connected these two lines. Now the reflect is going back to the generate. So what else is left? Alright guys, looks like everything is done. So let's just go ahead and compile the graph. So I'm just going to give it a constant named app, and then I can just say graph dot compile, and this should compile the graph. So before I actually, provide a topic for the tweet or provide an existing tweet and ask it to make it better, before I do that, I just make sure that, the graph is looking exactly how I expect it to, just to get ahead of any problems that may happen, right? So to do that, I'm just going to copy paste a few lines of code. So basically what this is doing is that, this is going to give you a mermaid diagram and an ASCII diagram. Basically it's like a very simple visualization of the graph. So right here, everything is like neat and tidy, but we just need to make sure that it is the same thing that is being replicated right here as well. And just one more thing, guys, if at all you get stuck anywhere, you've got two options. I'm putting this repository in the description below, so you can always go pull the code and then run it yourself, and that is sure to work. And if at all, despite that, you're getting some clarifications, I'm more than happy to answer questions in the comment section. So just go ahead and shoot your questions. So yeah, so as I said, this is going to give you the mermaid diagram, and this is going to give you the ASCII diagram as well. So let's go ahead and run it. And if you go ahead and run it, there is going to be one additional package that it might require you to install, and that is going to be this pip install grandalf. Okay, so just go ahead and install it, and you should be able to run it without any problems. So let's go ahead and run it, and let's see what happens. All right, so perfect. So this is going to be this first one is going to be the mermaid diagram. So as you can see, we've got the start is going to the generate, right? The start is going to the generate, and here there's going to be a simple edge, whereas the reflect going to the generate is also going to be a simple edge right here, right? So these are the two simple edges, whereas this generate going to the reflect is going to be a conditional edge, and that is exactly why we have the dot in the middle of this particular arrow. The same thing for the generate going to the end as well. So it is looking pretty well, and also you can see that we've got this other diagram as well, where the start is going to the generate and the generate is going to the reflect and the end. So everything is looking fine. So now what I'm going to do is I'm going to provide it a tweet, right? I'm just going to, basically this is a system that really helps me churn out really viral tweets really quickly, and I just need to provide it a topic or some context, right? So what I'm going to do is, so we have the app right here, and what I'm going to do is I'm just going to say app dot invoke, and inside of this I'm just going to pass in a human message. Okay, so basically whatever we pass in here, it is going to be added or rather appended to the existing list, the message history list that I told you about, right? So this is going to basically let me just type it out and let me explain it on the way. Okay, so the content is going to be, I want there to be a tweet written on AI agents taking over content creation. So I'm just going to say AI agents taking over content creation, and I'm also going to, assign it to this response and then print it out as well. All right, so let's hope that everything works fine. So essentially, if I were to hit play, what would happen is that this human message is going to be, that the entry is going to be the generate node, right? So this state, which is going to be a list of messages, right now it is only going to have one message, right, which is the human message that we are providing, and that is going to be put in the place of this variable message in the generation chain. So each of those chains would have their own individual system messages, but the history is going to be shared. It's going to be shared between both of those chains. Okay, so this is a confusion that a lot of people get. There is only going to be one message history. Okay, there's not going to be two message histories, just one message history. The system message is going to be separate for each of the chains, and both of those chains are going to share the increasingly getting message histories. I really hope that I'm not confusing it, but if at all you have any questions, ask me or just go ahead and ask ChatGPT. So yeah, let's actually go ahead and run it. Let's make sure that everything is fine in the chat, the chains as well. Okay, so let's go ahead and run it. Okay, so the diagrams are getting generated. Okay, it's taking a while because you can imagine that, okay, so it's actually here, guys. So you can see that, great. So you can see that the first human message that I've provided is right here. And then there's going to be a lot of other information like, okay, so the AI message is also here, right? So yeah, this is going to be the first creation of the generation chain, right? So we have the AI agents are revolutionizing content creation from automatic tedious tasks to generating creative text formats. They're empowering creators to focus on what matters most, right? And then, what matters most, telling compelling stories, and we've got several hashtags it has provided. So the generation chain has did its work, right? So I'm providing it a title and the generation chain is doing its work properly. So now what would happen, the reflect chain is going to critique that tweet that the generation chain has generated. So let's see where that is happening. I know this is a little not really that readable, but don't worry, we are going to be deep diving into what is exactly happening in the next section, where we are going to be tracing everything using Langsmith. But for now, you can see that. Great. So this human message is right here. So if you remember, we tried to mimic a human message getting. Basically, the critiquing voice is going to be a human message because that's how we're doing it, right? This makes it very readable for us. We can put it as a AI message. We can just leave it as it is as default. But because we put it as human message, this is going to be very readable for us. So here, this is going to be the critique, right? So your original tweet was concise but lacked context and excitement. It presented a statement without engaging the audience or offering any further information. While brevity is good, it needs to be paired with impact. Okay, and it is also providing recommendations. So the length, the revised tweet is slightly longer, providing more context while remaining. You can see that it's providing a lot of different things, right? This is amazing. So if you actually you can just pause the screen and then give it a read, you would be able to see that human message is critiquing it, and then the AI message is again like making it better, and the human message is critiquing it. And let's see how many iterations would it go for. Okay, so right now we've just set it to 2 iterations, guys. So you can actually increase it to, let's say, 4, and let's see what happens. I'm just going to increase it to, let's increase it to 6. I want there to be 3 different iterations, back and forth, back and forth, back and forth. Okay, so if I were to do that, let's see what happens. Usually, it's not going to be enough. There needs to be at least like a couple of iterations for the tweet to really, get become a viral tweet, right? So let's give it a let's give it a while. Okay, so it looks like it gave an error. It is saying that the iterations, this thing has been exhausted, and usually this tends to happen when you're not really paying for the API. So usually, since we're not paying for Google Gemini, they basically rate limit us. So we can only make these many subsequent calls at this particular interval, like something like that. So that becomes kind of an issue sometimes. So what I'm going to do is I'm just going to quickly switch to OpenAI because that is what I'm paying. So what I've basically gone ahead and done is that in the uh, so basically what I'm going to do is I'm going to go to chains and I'm going to use the LangChain OpenAI chat model. Okay, so now I want to communicate with the OpenAI chat model, and let's also go ahead and say chat OpenAI, and I'm just going to quickly come down here and then replace the model to GPT-4o. GPT-4o, all right, and let's save this. And I'm also going to provide the environment variable. Okay, so just go in here and then you can see that this is the environment variable that you need to provide. If you do not know how to pay for this thing, just go to platform.openai.com. I think go to the billing section and then you'd be able to pay a minimum of $5, and that is going to give you access. You can also pay for Gemini, but yeah, this is what I've already paid it, so I'm just going to go ahead and do it with OpenAI. So, all right, so let's now try to run this file again now that I've changed it, and it should hopefully work fine. So I've said GPT-4o, which is correct. Perfect. All right. Now let's try to run this again. So this time there's going to be, three different exchanges, right? So there's going to be six. The length of the message list is going to be six. So there's going to be three different iterations. So let's wait and see. Okay, perfect. So looks like we've received the entire thing. Okay, you can see that this is a pretty long message, right? Because there's quite a lot of data that is packed in here. So first off, there's a human message, and then this is going to be our initial message, and then there's going to be somewhere in here, you should be able to find the AI message generated. So where is it? Oh, right here. Okay, so we have the AI message generated, and there should be another simulation of the human message that is going to critique it. So yeah, so you can see that there's a human message right here. Your tweet touches an intriguing and current topic, but it could benefit from more context and engagement tactics. So again, there's going to be another AI message. Okay, so I'm not really able to find it here, but this will all make sense, in the next section where we are actually going to be tracing the entire thing using Langsmith.